Hello, welcome to this session. In this session, we are going to study uses of resistors. The first use of resistor, the most frequently used use of resistors is a voltage divider. So, voltage divider is used in many circuits to turn on circuits based on the signal voltage. So, we start first by constructing a voltage divider and then use this voltage divider in a switching circuit. So now I'll turn on QUCS for this. Now I'll create a new project. I'll call this voltage divider. So you have this voltage divider project with the untitled schematic page. Now we go to the components folder and the drop down we select lumped components. I will now choose resistor from the components available. I will rotate this by right clicking on the mouse button. Now I'll position it 1 and I'll position another resistor R2 and I will escape the command. It's enough you have 2 resistors. Now we have to add a voltage source. So I go down to the component distribution drop down and I select sources. From the sources I select DC voltage, position the DC voltage somewhere. Now I will escape the command. Now I go to add the ground signal. So this is the ground signal. I will keep, you can have one single ground signal or you can have two different ground signal, but the ground is only one ground. It doesn't matter how many instances you use. So these two ground symbols are instance of the same ground symbol. Now let's start wiring the circuit. So I am clicking this wire button and start. I click at the connection point of one component and reach the connection point of another component. Click. So when you want to change its direction, just right click and reach out to the connection point and left click on your mouse. So we have completed the circuit. So you can even use escape on your keyboard to escape the command. Now I need to measure the voltage at this point. So I will name this label, this wire. I'll call this wire. I'll use wire label command and I'll come to this wire and click it. I will name it A. So this wire is named A. Now I will simulate this circuit. So I will go to my component drop down. I select simulation. I select DC simulation. Now there is nothing else we need to do at this point. We need to merely run the simulation. Either I can use the simulation button here or go to simulation and click simulation. You see the keyboard shortcut is F2. So henceforth when I simulate I'll be using F2. So the first thing it will ask you is to save your schematic file. I'll call this voltage divider. Now it will run a schematic message, a simulation message. If there is no errors, it will lead you to another page called voltage divider.dpl. While voltage divider is the name of your circuit, so .sch is your schematic page and .dpl is your data page. Since there is only one parameter and only one instance, I will choose a tabular display. This tabular display will follow my cursor. I'll just left click. it will open into a dialog box asking you what property you want to display. So I will select the parameter I want to display. So it's going to be A dot B, means voltage at A. So I click apply and click OK. So it's 0.5 volt. Now I set it at, so by default value for this R1 and R2 was 50 ohms, but it's not advisable to have such a low value of resistance in a divider circuit. So we normally try to increase the impedance so that the strain on the signal source is as low as possible. So we select the resistance R1 and click edit properties, and then you see there are a list of properties available. So now I select this 50 in the 50 ohm, change it to 1K and apply and click OK. Now I need not select the component. I can select the value alone and type in 1K and enter. Now we'll run the simulation again. So I will click F2 on the keyboard to run the simulation this time. So it's the same thing. What would have happened? I will add the current from your. So is it correct? So we have, the total resistance is 2 kilo ohm, and 1 divided by 2 kilo ohm, it is going to be 5 into 10 to the power of minus 4. So it's correct as per Kirchhoff's voltage law and current law. It will show the current from the voltage source in the negative because current is leaving the voltage source. Right. Now we will go to the project and save this. We will again come back to our voltage divider. So you have this voltage divider circuit here. Now I want to show how a transistor will react to a signal. So what we do, we come to components. Instead of components, I'll come to library. I'm going to use a real transistor, a transistor that you can buy in the market. So you have got, these are libraries of components that are available in the market and that which have simulation possible. So I will choose a small signal transistor. So I find there are a lot of transistors available here. I will choose DC547, which should be a very good transistor, which is available very easily. For 548 is also okay. I'll select 547, 548C. I'll select this, and so you have this along with your cursor like this. Now I'm going to add I'll go to the components, I'll go to the sources, and I'll click at DC source, and I will have another DC source for the powering this circuit. Now between the DC, so this is going to be my signal to the base. So I will use a small resistor. I'll use a small resistor. Let us say about 1K. And then I will have the ground symbols. So for ground, the keyboard shortcut is Control G. I select Control G. So you see, at once the button is pressed. So I'll position the grounds. Right? So it has been placed. Now For wire, inserting wire, I'm going to use Control E, which is the keyboard shortcut for control for wires. Now so that's the extra wire here. So I'll just delete this by using the delete in the keyboard. I'll just click on the wire and it will go. Now I'll come back to Control E and continue my wiring. That is, you can pull the wires like this. I'll just remove this wire. Now here I will have one more resistor. This is going to be my load resistor. So this is also going to be 1K. And I'll complete the connection. Like this. And I will change this to 5 volts. So this is the circuit power. I'll remove the extra wire and then I will come to this one and I will, instead of 1 volt, I'll call it Vs. And then click OK and turn and then click OK. Now I go down to simulation. I select DC simulation and I'm going to test the voltage at this point. So it's going to be, let us call this B. Then what I'm going to do is, now since I'm going to vary this voltage source, I'll use another simulation called parameter sweep. I select this parameter sweep and position it. I can position all these simulation units anywhere in the circuit page. So what I'm going to simulate is I'm going to simulate DC1 and what parameter I'm going to simulate, it's going to be Vs, this one. So I will go and select Vs. Then it's going to be linear. So I will change from 0.1 volt to, let me say, about 1 volt. And I will, so this number is number of samples. I'll increase the number of samples to 2000 so that the graph is very smooth. I click OK, apply, and then I click OK. So it is ready for simulation. I go for simulation by pressing F2. Now I have to, so this is my transistor switch. So it's complete. Now I will use a Cartesian, which will be a two-dimensional graph. So I want to see how BV will vary with Vs. So this is my Vs. So when Vs is around 0.75 volts, your transistor switches off. Right? Now I will just change the whole thing. What I will do is I will add a probe. I will add a voltage probe across the resistor because the resistor R2 is the load. So I want to see what will be the voltage at the load. So I will connect this here. So I will measure the voltage across the resistor. Now I'll again run the simulation. Now I'll just right click this. If I go down, I find that there is one PR1 which I'll add it to this. So, so this is the voltage across the resistor. So your resistor is switched on while your transistor is switched off. So if I use the output at A, that is in blue, that is B, then I'm using the transistor as a switch. But instead of the resistor, I can have anything else, any other circuit like relay or LED light or anything. Then it will turn on when the voltage crosses. So I can use a marker. I can use a marker on the graph and find out where exactly it becomes 1 volt. So at Vs equal to 0.7, your BV is 2.4, or you have turned to 1. So actually your 1 is on this portion. So to be more accurate, what you can do is you can also select a tablet display. So I will select a tablet display and I'll select BV and PR1. Now you see you have this tabular column. So you have this spinner here which you can keep on working. So you see at one point it will change. So just pull down the slider. So it's slowly showing decrease of. Wait a minute, we overshoot this. So you see at from 0.7 onward it sharply declines to we reach 0.1 volt when you come to around 0.75 volt in the signal voltage. So it's going to be around 0.8 volts. I think it is around 0.75 volt when you're. So okay, let us assume that your thing will shoot up to logic 1 when there is. So this is my logic. So if I'm using the transistor as a switch, as an inverter, then the blue line is my logic 1. But if I'm using it to drive some other device, then the red curve is my utility curve. It tells me when that device will be turned on. So now we go back to our voltage. So we are going to use this kind of a switch in our voltage divider circuit. So I will save all and then go back to voltage divider. So I have got two circuits in this. So I will select voltage divider circuit. Now in this I am going to add a voltage divider. So it means I must set the value of this R2 or this R1 so that it is 1 volt when there is going to be a source. So it must give me 0.8 volts. So obviously I can raise this voltage. I can keep it at 1.1k. So I will try again simulation. I think we need to increase more. What I will do is I will change this to Rx and I will go to simulations. I'll take a parameter sweep. Now I select this parameter sweep. I select DC1. Then my variable is going to be sweep parameter is Rx. So it is going to move from 1k to, let us say, 1k ohm to, let us say, 1.5k ohm, and I will have lot of samples. I will have around 2000 samples. So the more number of samples, the better your curve. Now I run simulation by clicking F2 and I got this. So I can remove this V1. So either you look at this point or we can use the Cartesian. So you see this is my Cartesian. It seems I need more value than 1.5 volt because we have not yet reached 0.7 volts. So what I will do, I'll come here and change this to 2k, from 1k to 2k. 2k. I'll go in the order of, let us say, I'll step by 100 ohms. Let us see what happens. I made a mistake. Wait a minute. There are two Ks. Okay. Let us see if it works properly. So we have this. Even at 2k, we are yet to reach. So I think we must. Okay, I'll keep it at 2k. So what I will do is I will have 2k ohm, and then I'll select this and convert it to Vs, and then now I'll position this somewhere here so that they are not within the, they don't obstruct my circuit construction. Now I go to library, I select this 454 BC548C and bring it along like this. And then I need a load resistor, so I'll select R1, copy and then paste. I'll position it somewhere like this. I'll also make a copy of V1. Sorry. I will select and copy. You can even use Control C and Control V to paste, just as in any Windows. So I'll change US U equal to 5B and enter to register the change. So I will draw my wires. So you can draw your wires like this also. So if you have the habit of drawing wires like this, don't feel bad. It can also be done like this. So your voltage source is different and your signal source is different. I have completed this. Now I have to change the parameter. So my parameter is going to be Vs. It's Vs. Vs is going to change from 0.5 volt to, let us say, about 1 volt, and I will change 2000 times. So I have a very smooth curve. Now let's run simulation. So now I will change this. Oh yes, I forgot to add a label here. So I will add a label here. So this label I'll call it B, and then run simulation again. So now I will select BV also, that is voltage at B. Then I'll have to change voltage source voltage to around, I'll say I will go up to 3 volts and run simulation again. So you see the transistor has been switched off to at exactly at around 1 volt it has switched off. So supposing I change this to 2.2K, let us see what will happen. So we are still closer to this 1 volt. So of course at 1 volt it will start dissipating and it will start decreasing. So I'll keep it at 2 volt, 2 ohms, 2K. Right. Now see the output of the transistor is in the form of a curve. So it's turning slowly off until it reaches this. So this is how a single transistor will act as a switch. But supposing I want to increase the sharpness of this voltage, then what I do is I have two switches in tandem. I select the R3 and my BC548C and Control C, make a copy, and Control V. I paste this set here. Right. Now I will complete this circuit. So emitter is going to be grounded and the collector resistor is going to be connected to the. Now the input to the second transistor comes from the output of the first transistor. So now I will change this to C. I'll change this to C. Now I run simulation again. Now what I will do is I will go here and add C as well. We need to see how C is going to be. So you see that C is a perfect rectangle. It switches sharply. So this combination, I will add a rectangular block. I'll use the painting command and draw a rectangle to elaborate this. So this circuit is called the schematic trigger. So I use the schematic trigger to immediately to make a very sharp rays like this. So probably if I now use, instead of 2K I use 2.4K, then probably my C will be more sharp. So we are almost near 1.1 kilo. So when the signal is at 1 volt, your switch, your C output of your schematic trigger will reach the your positive rail. So this is how a voltage divider works. So it is turned on when your Vs is at 1. Right. So when the signal is at 1 volt, it increases. But when the signal is at 1 volt, your you can use a marker at this point. So at this point, A is 0.703. So the input voltage has to be 703 for the base of the transistor to give you 1 volt at the output, or give you a logic 1 or give you a logic high at the output. So a voltage divider is used in any typical circuit which uses the sample voltage, the sample signal, creates a sample of the signal and uses the sample signal to turn on or turn off any equipment. So anywhere where they are going to sense a signal and sample a part of the signal, then you are going to use a voltage divider. So this is the use of voltage divider, and this is the first use or most frequent use of resistors. So thank you for watching this session. See you again in the next session. Good luck.